Okay, class, we are going to pick up where we left off. We calculated, well, actually, we went through our Truss checklist, and we have developed this free body diagram, and now we're going to start finding the magnitude and the direction of our internal member forces, starting at joint E. Okay, so according to our Truss check sheet, analyze each joint of the truss, starting with the joint you think is easiest. Draw a free body diagram for that joint. If a joint has a diagonal force, draw a second free body diagram that shows the diagonal force and replace it with its components. Okay, so that's what we're going to do. First, let us draw our free body diagram of joint E. And we're going to draw it just as we see it right here. So here is joint E. And let me zoom in just a little bit. Okay, so here's joint E. And we have force. This is force CE. Okay. We do not know the magnitude of force CE. However, force 1, we know the magnitude of force 1, and that is 100 pounds. Okay. And we have a diagonal force, and that force is force DE. Okay, we do not know the magnitude of that force. Okay, so since force DE is a diagonal force, we're going to draw a separate free body diagram of force DE. And let's go ahead and do that. And we call this force DE. And we are going to draw the components of force DE, and we're going to call this force DE going in the Y direction, and we're going to call this force DE going in the X direction. And we have our angle right here, 36.87 degrees. Okay. Now we're going to start finding the sum of forces. Now we're going to use the sum of forces to find all of the magnitudes and the direction of our internal forces. So given that the only information we have is the external force that's going in the positive X direction of force 1 of 100 pounds, I'm going to start calculating sum of forces at in the X direction. Okay. So firstly, we have 100 pounds, positive 100 pounds. And then we have force DE X. So that's going in a negative X direction. So we're going to say force DE. And since that's our X direction and that component is adjacent to this angle, I'm going to say this is cosine. Cosine 36.87 degrees, and that must equal to 0. Okay. All right, so now let's just go ahead and solve. So we need to bring FDE cosine. And now we have force D E cosine 36.87 degrees, and it's equal to 100 pounds. Okay, so since we are trying to find the magnitude of force DE, we need to bring that cosine over here. So we're going to divide by the cosine 36.87 degrees. This will cancel out. Now we have force DE equals 100 pounds divided by cosine 36.87. And when I do the math, we're going to go 36.87 cosine divided by 100 pounds, and we're going to inverse that answer, and we get positive 125 pounds. And since we drew everything in tension and we have a positive number, we know that this force and magnitude is in fact in tension. Okay? So what I'm going to do, not only I'm going to update my summary sheet, I'm going to notate on my free body diagram force DE, and we have force DE. This is in fact in tension. Okay? Okay, now that we found our forces in the x direction, we found force DE. Let's go ahead and find the forces in our y direction. And I'm going to try to squeeze it on this page. I'm going to attempt to. So let's do one of these numbers. Okay? So we have sum of the forces going in the y direction equals 0. And we have a negative force CE. So we go negative force FCE. And we have a negative force DE going in the y direction. So since that y is opposite the angle, that's going to be a sine force DE. So what I'm going to do is I'm going to go negative force DE sine 36.87 degrees equal to 0. Okay, since I don't have okay, let's just continue on. So what I'm going to do is bring force DE sine 37 to the other side, and that would be negative force CE equals FDE sine 36.87 degrees. Let me zoom in. Okay, so let's just go ahead and just substitute and solve. So we already know force DE is a magnitude of 125 pounds. We found that. So we're going to go 125 sine 36.87 degrees. And let's just go ahead and solve for that. It's getting a little messy, but that's okay. So when I do the math, 36.87 sine times 125 pounds, and we get 75 pounds, but we're not finished. Negative force CE. Okay. Alright, so we're going to get rid of this negative. Negative 1 minus negative 1, and force CE equals negative 75 pounds. What does this mean? We have a negative number. That means the method of forces with regards to drawing all of our internal forces as tension, we know that force CE is not in tension. It is, in fact, in compression. Okay? So what I'm going to do, since this is a negative, I am going to go to my free body diagram, and I am going to change the direction of these arrows because they are not in tension. It is, in fact, in compression. So I'm going to erase this. And I'm going to erase this arrow. And I'm going to notate that this is in compression. So on my summary sheet, I'm going to go to my summary sheet, and I am going to notate for CE, a magnitude of 75 pounds, is in compression. Okay? So what I would like for you to do, let me zoom out. Everything we have done thus far, I want you to apply it to the rest of the joints. We have already found the magnitude of force DE, force CE at joint E. Now I want you to go to joint C, and I want you to just practice this process. So we already know the magnitude of reaction force CX, reaction force CY. We know the internal force, the magnitude of force CE. Now we need to find the magnitude and direction of force CD and force BC. Okay? So apply what we just learned from joint E to the rest of the joints. Okay? And if you have any questions, inbox me via Canvas and I will respond to you. Okay? All right. Happy studying. Peace.